Hi friends, welcome to the next session of the subject Engineering Mathematics. In this session we discuss classroom workbook. In last two sessions we have solved questions up to 21. Now let us start question number from 22 onwards. So what is this? If A equal to 5 by 5 matrix 0, 1, 2, 3, 4, minus 1, 0, minus 9, 8, 1, minus 2, 9, 0, 2, 8, minus 3, minus 8, minus 2, 0, 9, minus 4, minus 1, minus 8, minus 9, 0, then that A equal to what? This is highly workful question. See, this is not so simple to evaluate because its size is 5 by 5. Do you feel that any two rows are same in this matrix? No two rows are same. No two columns are same. Even some elements were positive, some are negative, and mainly diagonal elements are 0. That means one clue from this question is it is a skew symmetric matrix. Now this is a skew symmetric matrix. So it is clear that A equal to minus A transpose. Therefore A is a skew symmetric matrix. Since A is a skew symmetric matrix, all diagonal elements are 0. Now since it is a skew symmetric matrix, is there any way to find its that value? What is the size of this matrix? 5 by 5. 5 by 5. Now if you try to find its det value by expanding any row or any column, it takes lot of time, because in every row there is exactly 1 0, or in every column there is exactly 1 0. So if you expand that value by using any one of the rows or any one of the columns, still you need to find 4 pairs of determinants of size 4 by 4. So you need to find exactly 4 determinants of submatrices with the size 4 by 4. Again for 4 by 4 it takes 3 by 3 submatrices. So it is a very complicated procedure. Now in this case, let us try to find this by using definition of symmetric matrix and properties of determinants. Here A equal to minus A transpose. I want det A. So this implies det of this matrix is det of minus A transpose. This implies det A equal to, this is the det of Ka. So det of Ka is K power n. So n means size of this matrix, its size is 5. So minus 1 whole power 5 into det of A transpose. So this implies det A equal to minus 1 whole power 5 is minus 1. We know that det of A transpose is det A from properties of determinants or examples. So from this 2 times det A equal to 0. This implies det of this matrix is 0. See the magic in getting the answer. Just we have applied various properties of determinants or examples on determinants followed by definitions. This is the magic with definitions, examples. Just only 3 points. One point is the definition of skew symmetric matrix. Here A equal to minus A transpose. But I want det of this matrix. Apply determinant on both sides. So at this moment it is in the form det of Ka. What is det of Ka? K power n into det A. But A means A transpose. Now this is minus 1. But det of A transpose is det A. Therefore when you simplify this, you will get det A equal to 0. See, what is the speciality in this case is the speciality in this case is its size. Its size is odd. And this is a skew symmetric matrix. Suppose if this is an even number, minus 1 whole power even number is again plus 1. In that case you will get det A equal to det A. So if det A equal to det A, you won't get anything for det A value, because det A equal to det A means 2 equal to 2, 3 equal to 3, 4 equal to 4. Infinitely many possible values may come for det A. So which is not so simple to analyze. But the interesting property in this case is the magic in this question is it says Q symmetric matrix with odd size. Therefore, the conclusion from this is the determinant of any skew symmetric matrix of odd size is always 0. What it is? The determinant of any skew symmetric matrix of odd size is always 0. First, write these points. Note, the determinant of any skew symmetric matrix, the determinant of any skew symmetric matrix of odd size is 0. The determinant of any skew symmetric matrix of odd size is 0. Now let us move to question number 23. What it is for the matrix A equal to cos alpha minus sin alpha cos alpha, comma, det of A transpose into A equal to blank. So for this matrix A, you need to find det of this combination. Now it is in the form det of AB, or even when you observe this matrix, A is an orthogonal matrix. A is an orthogonal matrix. Since A is orthogonal, A into A transpose equal to A transpose into A equal to I by definition. Therefore, at this moment, this A transpose into A is I. Det of identity matrix, it is 1. In this question, if you don't get that this is an orthogonal matrix, you can do it manually. You can do manually like this. They ask you det of A transpose into A. So it is in the form det of AB. This is det of A transpose times det A. So transpose this, its det becomes 1. Its det value is again 1. So its answer is 1. Next we move to question number 24. Given that det of 130, 264 minus 102 equal to minus 12, then det of 260, 412, 8 minus 204 equal to blank. So the det of this matrix is given as minus 12. We need to find det of this matrix. That means there is a connection among the rows from this matrix and from this matrix. There is some connection. So try to find the connection between these two matrices. If you are unable to find the connection, generally when the questions were given like this, definitely there will be some connection among rows between two matrices. Therefore, basically, this is A, suppose. Now you can see the first row is multiplied with 2. This second row is multiplied with 2. Third row is multiplied with 2. Therefore, this matrix is 2 times of this. Therefore, this is 2A, matrix wise, just matrix wise. But they want det of 2A. So, it is in the form det of Ka. According to properties of determinants or elementary row operations, so det of Ka is K power n into det A. But here size of this matrix is 3. So, therefore, this is 2 cube into A. This is 8 into minus 12. So, this is minus 96. Yes, we discussed question number 25. Just go through question number 25. Perform the following operations on the matrix. A 3 by 3 matrix is given. Let us see what are the operations. The first operation is add the third row to the second row. So that means second row is getting modified. So this is my operation. R2 equal to R2 plus R3. So that means this is equivalent to this. We are adding third row to the second row. That means second row is getting modified. What is the next one? Subtract third column from first column. Subtract third column from first column. That is first column is getting modified. So therefore, from first column you need to subtract third column. That is C1 implies C1 minus C3. Elementary row operations, elementary column operations. Assume that the matrix is A. What it is? The matrix is this. A equal to 3, 4, 45, 7, 9, 105, 13 to 195. 13 to 195. So what is the question? The determinant of new matrix is. So when you apply this operation 1 and operation 2, this matrix will be changed, so that I assume that this is matrix B. Now its size will be again 3 by 3. This is original matrix. We have applied these two operations. We added third row to the second row and we subtracted third column from first column. As a result, we are getting new matrix B. And they were asking what is the det of this matrix, right? See, the logic involved in this question is when you apply third category row operations, basically these are in the form Ri implies Ri plus Krj, right? Ri implies Ri plus Krj. Of course, I value is not equal to J. And this is equivalent to Ci implies Ci plus K into Cj. Here also I value is not matching with J. Therefore, when you apply these type of operations, det value does not change. Therefore, this det B is equivalent to det A. This det A. Now this det A is 0 because when you observe columns, third column is 15 times of this. 3 into 15, 45. 7 15 is 105. 13 15 is 195. Here det A is 0 because the reason is column 3 equal to 15 times of column 1. Therefore, the det of this matrix is 0. Suppose if you don't identify this property, then if you do manually the det of this matrix B, it is complicated because when you apply this operation, second row is getting modified. So 7 plus 13, 20. 11, 300. Numbers are increasing. So in order to waste our time, they gave the operation like this. To confuse the students, the operation is given like this. Even when you look at second operation, C1 implies C1 minus C3. This becomes 3 minus 45, 7 minus 105, 13 minus 195. It becomes, this column becomes minus 42. This becomes minus 98. This becomes minus 182. So numbers are becoming complex. So numbers are becoming very complex. So therefore, in this case, this just you identify that they belong to third category operations. Therefore, the data of this matrix is same as data of original matrix. Since there is a relation between two columns like this, the data of this matrix is 0. Now let us discuss question number 26. Go through handout, we discuss question number 26. So given that A is equal to some 4 by 4 matrix. This is A0, 3, 7, 2, 5, 1, 3, 0, 0, 2, 4, 0, 0, 0, B. 4 by 4 matrix is given with two properties. So one is det value. Det A is 100 and trace of this matrix equal to 14. And they were asking what is modulus of A minus B. So two elements were missed. One is small a, another is small b. So two properties are given. Det A equal to 100, trace A equal to 14. The logic behind this question is just you find trace of this matrix and make this equal to 14. You will get one equation which connects two variables A and B and find the data of this matrix and make this equal to 100. You will get one more equation in the variables A and B. Solve two equations in two variables, you will get values of A and B and subtract A minus B and find its absolute value. That is, make negative value to positive value if it is. Now let us see here what is my det value. This is 100 and trace of A equal to 14. Now let us at first find det value. Det A equal to 100. Now here last row contains maximum zeros. Let us try to find det value by expanding last row. This is 41, 42, 43, 44. 44 means sign is plus. Minus 1, this is actually A44. So the sign is minus 1 whole power 4 plus 4, positive sign. So therefore this det is B times det of 3 by 3. Eliminate this row and this column. So we will get this 3 by 3 submatrix. So it is A03, 251, 002. This is equal to 100. Now expand value by using last row again. So this implies B times 2 into det of A025 equal to 100. Now this is a lower triangular matrix. Therefore its det is product of diagonal elements. So therefore this is 2B into 5A equal to 100. So this implies 10AB equal to 100. This implies AB equal to 10. This is one equation. Now let us find another equation by using trace of A equal to 14. Trace means sum of diagonal elements. Diagonal elements are A plus 5 plus 2 plus B. Therefore From this you will get trace of A equal to 14. But trace means A plus B plus 7. A plus B plus 7 equal to 14. This implies A plus B equal to 7. So equation 2. Now let us solve A value, B value by two equations. Product of two numbers is 10. Sum of two numbers is 7. Therefore, the possible values are A can be 2, B can be 5. Or A can be 5, B can be 2. Two different values. So 2 plus 5 is 7. 2 into 5 is 10. 5 plus 2 is 7. 5 into 2 is 10. Therefore, in this case, when you find modulus of A minus B, you will get 3. Here also you will get 3. Therefore, either in this case or in this case, modulus of A minus B equal to 3. Note this. Next we discuss question number 27. Given that A, B, C, D are n cross n matrices, all are n cross n matrices, each with a non-zero det value, that is det A non-zero, det B non-zero, det C non-zero and det D non-zero. And even another one more information is given, that is A into B into C into D equal to I. Then they were asking inverse of B. So everything is, four matrices were given, every matrix size is n cross n and every matrix det value is non-zero, and A into B into C into D equal to I, they were asking what is B inverse. When you go through options, in option D it is given as it does not exist. See, det of B is non-zero, that means B is a non-singular matrix. When a matrix is non-singular, its inverse is possible. So option D is wrong. Now let us try to find inverse of B by multiplying with some matrices either on left side or on right side. So here A into B into C into D equal to I. So I need to find B inverse. So let us find the inverse of this matrix at first. Apply inverse on both sides. So A into B into C into D whole inverse is I inverse. So according to properties of inverses, this becomes reverse order. C inverse, D inverse, C inverse, B inverse into A inverse. I inverse is I. Now I want B inverse. So from next step onwards, I need to eliminate D inverse, C inverse and A inverse. So at first, I can eliminate either D inverse or A inverse. Now let us see. This is multiply D both sides. So D into D inverse, C inverse, B inverse, A inverse equal to, this is D inverse into I. Sorry, D times I. So this is D into D inverse is I. Therefore, this becomes C inverse into B inverse into A inverse equal to D. Next, you can eliminate either A inverse or C inverse. So just I multiply this equation with the C on both sides. C into C inverse, B inverse, A inverse equal to, this is C into D. Therefore, this becomes C into C inverse is I. So this is B inverse into A inverse equal to CD. Next, you multiply right side A. Order is important for us. So B inverse into A equal to CDA. So this implies A inverse into A is I. So B inverse equal to CDA. So the answer for this question is option number B, CDA, option B. Next we discuss question number 28. Given an orthogonal matrix A equal to 1 1 1 1, 1 1 minus 1 minus 1, 1 minus 1 0 0, 0 0 1 minus 1. 4 by 4 matrix is given. Of course, this is an orthogonal matrix. And they were asking what is A into A transpose whole inverse. This matrix combination we need to find. When you look at options, every option is a multiple of identity matrix. First option is 1 by 4 into I4. Second option 1 by 2 into I4. Third option I means I4. Fourth option is 1 by 3 into I4. See, it is a 4 by 4 matrix. You can find its transpose and then you can multiply A with its transpose. So up to that it is simple. But if you want to find the inverse of a 4 by 4 matrix, it is very complicated issue. The logic involved in this question is, it is an orthogonal matrix. That is the advantage thing for us. Therefore, this is an orthogonal matrix. Implies, since it is an orthogonal matrix, by definition, A into A transpose is I. Therefore, A into A transpose whole inverse equal to I inverse. The inverse of identity matrix is I. Just purely, it's a definition based question. As I mentioned in the last sessions, at least 1/3 questions, 33% questions of GATE will be based on basic definitions and concepts. And next 33 questions, 1/3 questions will be based on, there are some moderate level. And remaining 1/3 questions will be about top of the level. So if you concentrate on each and every area, then I think cracking GATE examination is not a big issue, or cracking IES or cracking any competitive examination. Always focus on more and more on definitions and basic concepts with a varieties of examples. From example to example, you may get different properties, right? So the advantage for this question is its orthogonality. Since it is an orthogonal matrix, A into A transpose is I. I need the inverse of A into A transpose. I inverse is I. Next, we move to question number 29. Let us read out. What is the minimum number of scalar multiplications involved in computing the matrix product PQR? The dimensions of matrices are given like this. See, in this problem we need to find PQR. Now this, officially there is no dot, but indirectly there is a dot between this. This is matrix multiplication. But they were asking what is the minimum number of scalar multiplications required in computing this matrix product. Let us see the dimensions of matrices PQR. What is the dimension of P? 4 cross 2. What is the dimension of Q? It is 2 cross 4. What is the dimension of R? It is 4 by 1. Now let us see in how many ways we can evaluate this. This PQR can be evaluated in two different ways. One is this way. First you multiply P and Q and multiply this result with R. And second combination is first you multiply QR and multiply with P in this order. This is a pre-multiplication and this is post-multiplication. So order is not changing. First P, second time Q, third, or order should not be changed. But in this case, first PQ is multiplied and then this result is multiplied with R. In this way, first QR is multiplied and then result is multiplied with P in this direction. This is a pre-multiplication and this is post-multiplication. Now let us try to find the number of scalar multiplications in this case and even in this case. So whichever gives least, that will be the least. Now let us find this case 1. See, for PQ, what is the dimension of P? This is 4 cross 2 and Q dimension is 2 cross 4. So in order to multiply this PQ, the total number of scalar multiplications is 4 into 2 into 4. So this equal to 32 according to the formula M cross N, N cross P. So if you want to multiply two matrices with the dimensions m cross n and n cross p, the total number of scalar multiplications required is m and p. So according to that formula, this becomes 4 into, this 2 is repeated twice, count it one time. 4 into 2 into 4, it is 32. But till now, we have calculated only PQ. Now what is the dimension of PQ? The dimension of PQ is, this is 4 by 2 and this is 2 by 4. It is 4 by 4. Now multiply this PQ with R. The dimension of R is 4 by 1. Now in this way it required m cross n, n cross p. It requires 4 into 4 into 1. Now it is 16. Therefore the total number of scalar multiplications in this by case 1 is 32 plus 16. This is 48. So therefore by method number 1, the total number of scalar multiplications required is 48. We don't know whether it is least or not. So let us try to find the same by discussing method number 2. So first let us evaluate QR. Q dimension is 2 cross 4. R dimension is 4 cross 1. So to multiply these two, the total multiplication is 2 into 4 into 1. So this is 8. Now QR dimension is, this is 2 by 1. Now let us multiply this with pre-multiplication P. What is the dimension of P? It is 4 cross 2. Now therefore in this case it requires 4 into 2 into 1. So this is 8. Therefore the total multiplications to get PQR in this case is 8 plus 8. This plus this. It is 16. So by method 2 it is 16. By method 1 it is 48. Therefore the least number of scalar multiplications to get the matrix product PQR is 16. Note this. Now let us discuss question number 30. What it is? The determinant of an orthogonal matrix of size 1996 cross 1996. The determinant of an orthogonal matrix of size 1996 cross 1996 can be. Just go through the options. Very interesting question. See, always try to understand, try to remember one point. If the dimension of a matrix is very complicated, some logic will be involved in that. Just try to identify that logic. The beautiness in this question is orthogonal matrix. If something is an orthogonal matrix, the det value is either +1 or -1. So when you look at the options, there is only one option with value -1. Of course, this question should not be given with two different options, 1 and -1. If it is like this, then two different answers should not be there. Got it? So therefore, in this case, there is only one option with a -1 and remaining values are neither +1 nor -1. Since it is an orthogonal matrix, irrespective of its size, the det can be either +1 or -1. But in the options, you can find we have -1. Therefore, the answer for this question is -1. But thank you so much. This is the end of this particular session. With this, we have finished classroom workbook for the first basic concepts. Right? Thank you so much.